We have said refractive index equals to, members, refractive index equals to real what? Real depth over apparent depth. And we know the difference between them. We know the difference between real depth and apparent depth. So for this experiment now, we are using a liquid. Liquid here, we have used a general form. But tomorrow in a question, they may say of water. So they may say of any form of liquid that you know. You can use it to define maybe the refractive index of soda. But we must have a clear distinction here. We said the liquid we are dealing with must be a transparent material, or it must be a transparent liquid. It must be transparent. So the best liquid that we can use here is water. The best liquid we can use here is water, because water is transparent. So that they are opaque, they're translucent. So that they're translucent, so they can allow all light to pass through them. So we have to take note of that condition. So now what do we need in this experiment? We need a beaker, and it must be a transparent beaker. It must be a transparent beaker. Why transparent? So that the reading can be seen clearly, because here we are dealing with measurements. We are measuring heights, or we are measuring depths. You should know the difference between height and depth. Depth, you measure it up, down, but height is measure up, down, up. So you should get a declaration between depth and height. Height you are measuring from ground or from down, up, but depth you are measuring from up, down. That is the depth. Okay. So what we need in this experiment, we need a beaker. We also need a retort stand. We need some pins. We need transparent liquid. Then we need a half-meter rule. The half-meter rule is to take the measurements. Are we together, members? Are we together? Members, are you following me?
Yes.
All right. So those are the things we need in this experiment. What's the setup? Let's look at the setup. So this is our setup. So can we sketch that? So maybe before we sketch that, I want us to watch this video. Let's watch this video, because this video is going to summarize all this experiment we are talking about, so that when we come back, we just take notes. Are you together? Because the video is just going to summarize. Because in this experiment, what we need, we have said we need the optical pin. So we need the pins. We need the beaker. We need a transparent liquid. Then we have an half-meter rule. So the setup will be exactly like this. So we shall have two pins. One we place at the bottom, then one we suspend it up. We clamp it on a retort stand. Then we keep on adjusting this pin here, this one here, the one we have clamped. We move it up and down until there's no parallax. That one, in other words, we call it also no parallax method. No parallax method. In other words, they should not be transparent. They should coincide. So the image, the refracted image of the pins, which is below here, which is down here, must coincide with the pins, which is put on top here. So when there are no parallax, when they are not together, because this one, the image of this will appear, will be displaced to a given point here. That's why you see this dotted line here, will be displaced to that point. So I think X is apparent displacement. X is apparent displacement. Are we together, members? X is what? X is what? Members, can you talk? X is what? Apparent?
Apparent displacement.
Then Y is what? Y is our real what? Real depth. So what? Because we said trust refined refractive index is real depth over apparent depth. So what will be real depth? What will be apparent depth? Mathematical apparent depth will be? Who can find us for apparent depth? Apparent depth will be Y minus what? Y minus X. Y minus X. So the procedures that are clear. The procedures are clear down here. The procedures are very clear down here. So, but for the purpose to us to understand the experiment clearer, or to understand better, so let's watch this video. Let's watch this video clearly. Let's watch this video. Are we ready, members? Are we ready to watch the video? Members, are we ready?
Yes.
All right. So this video is going to summarize everything here. This video is going to summarize everything. All right, members, let me hope you're able to see my screen. Members?
Yes, teacher.
Yes.
We are looking at we say refractive index equals to real depth of apparent depth. So let's watch it carefully.
In previous video, we have watched parallax and no parallax condition. Parallax exists because the image and the
Members, are you getting the sound? Can you hear anything?
Yes.
I can hear.
Good.
pin are not at the same level. There is no parallax because the pin and the image are at the same level. Experiments shown in this video may have slight difference from your school. Real depth is 4 cm from the object to the water surface. When the pin is at 1.1 cm, there is no parallax. Apparent depth 2.9 cm. We replay the video. Apparent depth is 4.0 minus 1.1. We get 2.9 cm. Apply refractive index formula, which is real depth divided by apparent depth. Estimation method, we got refractive index of water 1.38. Real depth is 4.0 cm. We adjust the position of the pin to 2.0 cm. Let's observe from different position.
So members.
Yes, teacher. Yes.
So you have got what I said, no parallax method. Because now when we talk of parallax method, no parallax, the image must coincide, which means they are not parallel to each other. They are what? They are coinciding together. They are what? They are coinciding. And that one we call it no parallax method. We call it what?
No parallax method.
Or sometimes they call it exclamation method. We call it exclamation method. So I want us to watch this one. This one I wanted to see the difference between parallax and no parallax method, but let's watch this one here.
Monica, I just sent you the email with the client
I'm looking at the
notes.
doc now, but I think it's an older version. Can you send an updated?
Monica.
Okay, this is experiment 6.2. This experiment's aim is to determine the refractive index of water using non-parallax method. Okay, so the manipulated variable is the real depth, the responding variable is apparent depth, and then the constant variable is the refractive index of water. So what we do is we set up the experiment. Okay, so before I start with the experiment, we will discuss a little bit of the basic concept of this experiment. Okay, the basic concept to this experiment is if the two pin is at the same level or the same position, then no matter from which angle you look at the pin will look like to be in the same position. Okay, so you see I changed the angle from the top. Okay, same position. From at an angle, same position. Okay, directly, also same position. Okay, you see no matter from which angle, it will look like to be in the same position. If the two pin is at the same position, then no matter which level you see, which angle you see, it will be at the same level. However, if the two pin is not at the same position, even at one position it looks like they are at the same level. When you change the angle, they will not be the same position. Okay, so this is where both pin is not at the same position. You change the angle, they will look like not at the same position. Okay, real depth is 6 centimeter. Okay, this is the setup of the experiment. After you fill up the water until 6 centimeter, you position the needle. Okay, you position the needle so that the needle, when you look from the top, okay, when you look from the top, the needle inside the water and the needle outside the water is at the same position. Okay, at the same position. But if you look at the side, okay, when you start to change angle, you see that they are not at the same level. So this means that the position of the needle outside the beaker is not at the same position as the image from the needle in the beaker. Okay, so we need to adjust. Okay, so we want to adjust the position of the needle outside the beaker so that it is at the same level as the image.
Members, are we following? Members, are we following the video? Yes?
Yes.
All right.
Yes.
Okay, let's summarize it. We have 2 minutes, 2 minutes remaining. Let's summarize the video.
In the water. Okay, you adjust the position of the needle outside the beaker until no matter from which angle you look at the needle, no matter which angle, from the top, same position. At an angle from the side, also looks same position. Okay, also same position from a few angle. So when it looks like it's at the same position from a few angles, so that means the needle outside the beaker is at the same level as the image of the needle. Then you can take the reading. So this reading is the apparent depth. Okay, the apparent depth of real depth 6 centimeter. Now we add water until the real depth is 7 centimeter. Okay, real depth at 7 centimeter. Okay, real depth 7 centimeter from the top. From an angle, okay, looks like same level. Can take
Members. I believe you have got the concept now. You have got the concept, right? Members, have we got the concept?
Yes, teacher.
All right. So now let's come back to our notes here. Let's come back to our notes. So you suspend a rotor stand like that. So can we sketch this? Can we sketch this? Can we draw this? So what are the procedures? The first step is we pour water in a beaker and measure the height, Y. And that Y is representing the real depth of the liquid in the beaker. You don't measure the height of the beaker, but you measure the height of the water in the beaker. Okay? Are you together, members? We measure the height of what? Water, not the height of the beaker. Okay? That's the first procedure. Then the second one, place a pin. Place a pin at the bottom of the beaker with its what? Point touching the side of the beaker. So like you have seen from the video, we have to place a pin horizontally. We place it horizontally at the bottom of the beaker with its point touching the side of the. Why do we make it to touch? So that it becomes very easy to adjust the pin which is outside, the one which is outside, because we have to adjust the one which is outside until it coincides with the image, with the image of the pin inside the beaker. So after doing that, support another pin on the clamp, now on the retort stand, at the side of the beaker using the porcelain. The porcelain is something sticky. Is elastic in nature, so we can use it for footing in the lab. That's what we use, like you have seen from the video. What the other person was using was that one. We call it the porcelain. This one here, we call it the what? The porcelain. Is also elastic in nature. So observe from the edge of the beaker and adjust the pin on the clamp until it appears to be on the same level with the pin in the water in the beaker. Now after that one, now we call it here, you say no parallax, until there is no parallax between the two pins, until they are the same level, until they are the same what? At the same level. Now when they're at the same level, now what you do, you take measurements. Now measure the height, measure and record the height X. What is that height X? We said height X is called what? Members, who can remind us? That height X is called what? It's called what?
Apparent displacement.
Excellent. X is called apparent displacement. X is called apparent displacement. Now, after measuring apparent displacement, now you must remember from the theory, we say refractive index is equals to real depth over real depth over apparent depth. Now from our drawing here, now what will be our real depth? Our real depth is what? Is Y, not so. Our real depth is what? Y. What about apparent depth? Remember, X is the apparent displacement. X is apparent displacement. So which means everything will be apparent depth will be Y minus X. Y minus X. Then our refractive index N will be equals to Y over Y minus X. It's not a must that we must put it to be Y minus X. You can use another letter to present apparent depth. Let me connect my camera so that I can also be writing. But first, be taking notes. Be taking the notes. Please be taking the notes. Okay? Are we together, members? Be taking the notes. Members, be taking the notes, please. Be taking the notes.
What is this? It's calculator doing here.
Members, members. Members, are you able to see my writing board, my writing space? Members, are you able to see my writing space?
Yes.
All right. So,
Teacher.
all right. So, apparent depth will be equals to y minus x, y minus x, y minus x. Then now refractive index, which we said is the real depth over apparent depth. So n will be equals to y over, but it's not a must, members. It's not a must. It's not a must. It's not a must for us to use y and y minus x. Someone can say, assuming this is now our sketch, according to our diagram, if this is what we have, assuming this is our setup, this is our setup. Now we are here like this. Like this. So this is the table. This could be the table. Then we have the retort stand. Now the pin is down here. Let's assume this is the pin. I'm just assuming, members. So the pin must be touching the side of the beaker. So now after adjusting, let's assume that after, due to refraction, now this pin will appear to be here. Will appear to be here. Now the pin which is outside is this side. Is this side. So they are coinciding like that. This is how they are coinciding. So we said, if this is the water level, if this is the water level, this is the water or the liquid. This is the liquid. So from here up to there is what? This one will be called what? This one will be our real depth. So we can call that one, we can call it capital H. We can call it capital H. Then this one here, this one up to here, this one here. This one will, what is this one? Members, what is this? This is apparent. This is apparent what? Depth. This is apparent. This is apparent what? Depth, which we can call it small h. Then we can call this one here. This one here. We say this one is called what? Apparent. This is apparent. Apparent what? Displacement. I can call it D. So now we can say refractive index N, which is equals to real depth, real what? Depth over what? Apparent depth. So N will be equals to, if I'm using this, will be H over small h. Members, have you seen that? What is important is to you to have a clear distinction between them. That's what we are trying to emphasize here. So you have to adjust this one. They must be at the same level, no parallax. No parallax. There should be no parallax. So they must be in the same level. They must be at the same level. The same applies if you are using for a glass block. If you are using for a glass block. Are you together, members? Are we together? Members, are we together?
Yes, teacher.
All right. So be taking the notes, put it down. Are we through with that? Members, are we through with that? So from here, in case, if it was cancellation, if they're asking for apparent displacement, we said apparent displacement is equals to real depth, real what? Real depth minus apparent depth. So which means D will be equals to capital H minus small h minus small h. So take note of that. Members, are we through with that? Are we through with that?
Yes.
Let me hope you have understood. Members.
Yes, teacher.
Who can describe for us in briefly? We have 1 minute remaining. Who can describe for us briefly this experiment? What do we do? What do we need in this experiment? Just describe it briefly. Who can describe it for us? What do we need? Yes?
Teacher,
Yes?
we need a glass block, a retort stand, transparent liquid.
For the liquid, we don't need a glass block. We need a beaker. It's a beaker. This is a beaker.
A beaker
Yes.
and optical pins.
Optical pins.
And
I mean
Yeah.
optical pins. Optical pins. How many? We need two optical.
2 optical pins.
Once we put it in the beaker, then one we put it what? One we suspend it outside, not so? So we put one here, then one outside, because now this one here will be displaced to a given point. So we have to adjust until they are the same level like this. Until they are the same level like this. Are you together, members? Until they are what? Coinciding like this. So then after that, we take the measurement. When we are taking the measurement, we don't measure the height of the beaker. We measure the height of the liquid column. We measure the height of the liquid what? Column in the beaker. So remember, the more you keep on adding the water, the more it will be displaced. Okay? So we measure the height of the water in the beaker. Height of the water in the beaker. So also down here, we need a transparent or a white sheet of paper. We place a white sheet of paper where? Down. Why do we put a white sheet of paper down, members? Why? Members, why do